Hello everyone, this is video number 5. In this video we are going to discuss about vectors. Now vectors are objects that have one is a type, will give us information about type of a vector. For example, force, velocity, acceleration, etc. The second information is a magnitude, how strong this vector is. And the third information is a direction. Now, how we can picture this vector? A vector has a tail, a head, and a straight line between tail and head. This straight line between tail and head will represent magnitude of a vector. Okay, the direction of a vector is from tail to its head. From this point, which is tail, to this point, which is head. Okay, this is our direction of some given vector. For example, force, velocity, or acceleration. Okay, how we denote a vector? We denote a vector by using letters, small letters or capital letters, for example. And of course a small arrow above those letters. For example, vector A or capital A and arrow above it. Vector B or capital B and arrow above it. Let's assume we have some vector that its direction from left to right. And we call this vector A. Or maybe we have a vector downwards and we can call it B. Okay, or maybe this vector, we can call it C. Okay, this is how we draw a vector. Now, how about magnitude? How we denote magnitude? Okay, magnitude of a vector. Suppose you want to talk about magnitude of vector A. Magnitude of the vector, suppose A, we will denote it as or just a capital or just a letter A, or like this. Okay, this is the same symbol for a magnitude of a vector A. Or maybe the second example, this is the first example, second example B, or like this. Third example, oops, without arrow, or this is how you denote a magnitude of vectors A and B. Okay, another example for a vector, it could be a force. Okay, let's assume you have some book on the table and the book stays still, which is, it has no velocity. It remains still. Okay, and suppose you want to move this book from this point to this new point. To do so, of course, you have to apply force. What you can do, you can either pull this book from left to right, and you use force F. F is a vector, this is your force, or this is a pull, okay, or you can push. Okay, this will give you the same result, And what is the result? The book will move if the magnitude of your force will be enough, okay, to move this book from its origin position to the new position. Let's assume the new position will be here. So force, okay, actually gives us three information: type of a vector, which is force, direction of this vector from left to right, okay, and magnitude, of course, which will represent this length of straight line between tail and head of this vector. Now, when we can say the two vectors are the same, two vectors or more vectors are the same if they have one, the same type. For example, they both forces, or they both velocities, or they both acceleration. Okay, the second is magnitude. They have the same magnitude. Sorry. And they have the same direction. For example, let's assume we have two force vectors, okay, F1 and F2. And as you can see, those two vectors have the same type, which is force. Okay, they have the same magnitude, as I can see, the same length of this vector, and the same direction. Then we can actually say, because all those three conditions are okay, we can say that those two vectors are the same. This is example 1. Second example, let's assume that we have vector F1, which its direction from left to right, the second vector F2, okay, it's downwards. Now, those two vectors have the same type, okay, type is okay. Okay, the same actually magnitude, the same length, okay, magnitude are the same. Check, but the direction is different. Direction is different. So, if direction is different, okay, but then we cannot say those vectors are the same, which means that F1 is not equal to vector F2. However, the magnitude F1 equals to the magnitude of F2, or you can also denote this as F arrow, like this. This is also represent the magnitude of those two vectors. Let's give another example. We have vector which will represent velocity, v1, okay, velocity, okay, and we have second vector, force, f1. Now, as you can see, the direction is the same. Direction is the same. The magnitude is the same because the lengths of those two vectors are the same. So magnitude is the same. However, the type is different. So we cannot say that those two vectors are the same, which means they are different. v1 is not equal to f1. Okay, I think I'm gonna stop here, and I will see you in the next video.